Hello everyone, and welcome to the demo for the CSED assignment by CTSE. We've implemented three microservices. The main reason for that, we wanted to focus on the course management microservice, but then we realized that without the author service and the API gateway, it is not complete. Therefore, we implemented three microservices and then implemented the CI/CD pipelines for all those three microservices as well. So we have the three repositories, and in those three repositories, we have three GitHub actions, basically very similar to each other, where we define jobs to build the image and push the image to Docker Hub, and then basically to deploy the actual container to EKS. For that, we also have GitHub secrets. We have gateway secrets for the API gateway one, authorization secrets for the auth service, and then also course management secrets for the course management service. And then auth service has some additional secrets such as the Google Client ID and Google Client secrets because we implemented OAuth and then slightly changed it a little bit. So everything is handled inside the microservice itself. And then once all of that is done, it will get the image from the Docker Hub repository. It will get the actual trigger from the GitHub action. And then you'll get the necessary secrets for the process by using the GitHub secret. So that is like the overall idea that we have. So now, if we talk about this, now let's if we talk about these repositories, we've also implemented some security features. So you can see here we implemented some checks using Trivy, and then we've also implemented Snipe. So to make sure that we don't have any vulnerable dependencies. So we did this in Node. So that's why you can see here there are some upgrades that Snag is recommending. And you can also see here that we've protected the main branch. So we've followed those necessary best practices in CI/CD in order to ensure that there's good security and good security practices. So you can see here we protected the main branch from every other branch. And then we've also implemented necessary security checks such as using Snipe and also Chivi in order to make sure that our security is on par. Now, if we go to our pull request, now I've created a dummy PR, you can say, for the demo purposes. Now, if everything goes well, as soon as we merge this, GitHub Actions should trigger. So now let's see if that happens. Okay. So now if we go to Actions, you can see here that there's a action already running it. So here we have basically two main stages. We have the build and push stage, and we also have the deploy stage. And while this is running, I'll also show a very, uh, very important, very important distinction between the two services, between the three services, you could say. So here we have our API gateway. In the API gateway, you can see here that the in the Kubernetes file, we've defined it as a load balancer, and here in the course management service, we've implemented it as a cluster IP. So basically, what we wanted to do was in this architecture, the basic idea is I'll go back to the architecture diagram as well for a bit. So the basic idea here is we have an API gateway, which is like the entry point to our cluster, and the actual auth service and the course management service is actually locked off to external users. So the external users can only access these services through our API gateway. In addition to that, in order to access the actual course management service, they need to have a auth code as well. So these are some additional, you can say, additional security precautions that we've taken in order to make sure that the resources that we are accessing using the course management service is authorized and authenticated, right? Yeah. Now, if we go back to our uh, GitHub Actions, you can see here that we have the git commit hash. So that is something we implemented as well. So rather than we basically tag the image with the git commit hash. Now you can see here that it's logging into Docker Hub. So that is done using the GitHub secrets. They build the Docker image, and you can see here the tree scan for vulnerabilities, and then we push the Docker image as well. And now if we go to the Docker Hub repository, you can see here that you can see here now if we refresh this, taking some time. But yeah, you can see here that this is the latest image that was pushed to Docker Hub. You can see here the last it was pushed in the last minute. Um, Yeah, now if we go back to the action, you can see here that everything was completed. So we completed the build and push stage and then also the deploy stage as well. Now let's quickly go to the deploy stage as well. Here you can see here we are configuring the AWS credentials. All of this is done using the GitHub secrets as I mentioned previously. And then we are setting up Kubernetes and then we are deploying it using Kubernetes EKS as well. And yeah, that is it. Yeah, you can see here. Yeah, this is the other thing I wanted to show. And you can see here that we've terminated the previous one, which was like 20 minutes old. And then we have the new deployment running, which you can see here, like 18 seconds long. So we also verify all of these in the GitHub action, like the CI/CD pipeline itself using GitHub actions. Yeah, with all of that done, so this is like these are the two other repositories that we have. So uh, if they get a push to the develop branch or the develop branch in this and dev branch in that, uh, both of them will act in a similar way because all the deploy files are very similar in all the three repositories. Now you can see here if you go to AWS, this is the EKS service, and here this is the microservices cluster that we created. And now, if you go to EC2, if you go to the dashboard, we have two instances running and we have load balancers. So these are like the common two load balancers that are actually required by AWS to kind of mitigate the resources. And this is the actual load balance that we created. You can see here by the name itself, like CTSE Microservice API Gateway. So that is like the name that we gave the actual load balancer that we defined. So that's right by attaching a subnet to it as well. We have already have a load balancer that is available to external users up and running. So now, if we copy this DNS, oh no, before that, so I have a API request. So if I remove this authorization header and then send this request, you can see here it says that authorization is required. So you cannot get into this resource without having a authorization code or access code. Now, if you go to this DNS address followed by slash API slash auth slash Google, which is the endpoint that we've defined for logging in, you can see here all of this is handled within the microservice as well. So we logged into the microservice, and with that, we have a access code as well. So now, if we go to Postman, let's paste this access token in the authorization token in the bearer token as a bearer token. So you can see here we can access the actual post content that is in the database. Now, if we go to the post one, so this is for posting course content. So I'm logged in as Dinar Senadira. So in that we don't have access to actually post content. Now, if I go to users, you can see here this is dinarsenadira@gmail.com and the role is user. So user don't have access to do this. Now, if I go to this post endpoint and then paste the actual access token that I got and then click send, you can see here I get the forbidden message and the whole user is not allowed to access this resource. So I already have some dummy data in the body as well. Now you can see here from my uh, slipped email, I have the role of instructor. So uh, let's quickly go to login again as a what do you call as a uh, as from a Slick email. So basically as an instructor. So I click my Slick email. Yes. So this is the correct one. Yes. Okay. Nice. So now I can get the tokens. So the main reason, again, something that should be noted here, the main reason why we had to show the user the token here is because we don't have a front end. So all of this had to be slightly tweaked in order to show the user the token and then using the token itself. So if we had a front end, it will be simple as setting this token as a cookie and then using that cookie for our purposes. Now, if we go here and then here's the new access token that we got and then click send, you can see here the new user, which is our user, the Slick email user with the role instructor, is now able to get in and actually create this course content. Yeah, so uh, that was the demonstration. That was the uh, demo that we created. Now, if you go to course content, sorry. Now, if you go to course content, it will be available as well. So you can see here, this is the course that we created, and in the users, we have this users as well who can access some of the resources but not others. So it is protected based on a role-based access, and then it is protected from vulnerabilities and such using Trivi and Snipe, and then it is actually protected from authentication access based on whether the user is logged in or not. Yeah, that is it. Thank you for listening.